All right, you guys, so the last little part here, it says write the equation that has the following transformations for its given parent function. So this says the graph square root of x is reflected over the x-axis, vertically stretched by 2, and vertically translated down 4. So we just need to put these transformations in the right spot, okay? So square root of x reflected over the x-axis, remember, is a negative in the front. But we're also vertically stretched by 2, so that means there's also a 2 in the front. And then we're also vertically translated down 4. So remember, down 4 is outside here with this. So we'll have f of x equals this. Okay, so that's the first one. Next one, we have a cube root of x. Okay, so let's see what we're going to do this time. So reflected over the x-axis again, so we know we need a negative out here. We are translated left 4, so remember, that means we need to do the opposite. So instead of going negative 4, we put plus 4 to go left 4, because really that means minus 4. And then 2 units up is a plus 2 on the outside. Okay, so that's the answer to that one. This one, square root of x. So this time we're reflected over the y-axis. So remember, reflected over the y-axis is a negative in the front. And actually, if you look, all of these things are horizontal. Horizontally stretched by a factor of 2, horizontally translated by 8 units to the left. So horizontal is a little bit trickier. So you really want to put this part here in parentheses. And we want to put like the left and right inside the parentheses, and then the like stretches and the reflections outside the parentheses. So we're reflecting over the y-axis, so that's going to be a negative in the front. We are horizontally stretching by a factor of 2, which remember, when we put it in, we lie to our x's, right? So whenever you put that in, you're not just going to put it in as a 2 like you do for vertical stretches. You actually have to put it in as the reciprocal as 1/2. Okay, so that one's a little bit weird. To stretch it, we actually have to put a 1/2. And then to go to the left, remember, once again, is opposite. So you would think left is negative, but really it's going to be a positive. And that's it. So this is one way they could write it. But most of the time, the way that they write it is they actually distribute this in. And so most of the time will be written like negative 1/2 x, and then negative 1/2 times 8 is negative 4. So most of the time it'll be written like that. Okay, so this is really probably what you'll see on most things like that. Okay. All right, and then the last one here is this word problem. It says the number of people at a Georgia Tech football game as a function of time in minutes since the gate opened is represented by the function this. Okay, it says graph the function using appropriate labels and scales. Okay, so first thing, let's go ahead and graph, or like find what our points are. So this is a square root, so we'll use our square root parent function chart. Okay, and then our new chart, actually nothing is happening to the x's in this one. So the x values are going to stay the exact same. So I can write those down, 0, 1, 4, 9. Those are going to stay. But the y's, remember, everything outside affects the y's. So that's going to be 200 y plus 100. Right, we got to stretch them by 200 and then move it up 100. Okay, so if we plug in our y values here, we'll have 200 times 0, that's 0, plus 100 is 100. 200 times 1 is 200, plus 100 is 300. 2 times 200 is 400, plus 100 is 500. And then last, 3 times 200 is 600, plus 100 is 700. Okay, so now we have to figure out what we're going to count by, because you can see the y's are going by like hundreds. So I would probably count by 100 then, right? Kind of logical. So on the y's, I would count by 100. So 100, 200, 300, 400, 500, 600, 700. I'm going to stop because you get the picture, right? We're counting by hundreds. And if we need to label this side as well. So let's think about what our y value is representing. So remember, if we have time is always going to be our x, okay? and then whatever else is going to be our y. So in this case, we have number of people in a football game as a function of time. And so the time in minutes is going to go down here. I'll just go ahead and label that time in minutes. And then on the other axis, we're going to have number of people. Okay? So make sure to label that. But then for our x's, we're just going to count by ones because you see how like we just go up to 9. So there's no need to really count by anything other than ones. 5, 6, 7, 8, 9. Okay? And then from there we can just plot our points. So 0, 100, 1, 300, 4, 500, and 9, 700. And remember, square root functions look like that, right? Okay, so that's that. Okay, and then the very last question says, how many minutes does it take there to be 560 people at the game? So if we think about where we're going to plug that into the equation, people, remember, is the y's here, right? So we're going to take this and plug it in for y and solve for x. We're solving for how many minutes it takes, right? So we'll have 560 equals 200 square root x plus 100. So we just set the equation equal, to 560, and then we just solve this, okay? So the way you solve it, we're trying to get the square root by itself, so we got to subtract this over. So that is 460 equals 200 square root x. Okay, so then remember when there's a number multiplied in the front, we got to divide it to the other side. Okay, so let me type that in really quick. 460 divided by 200 is 2.3. Okay, and then the last, to solve for x, we just square both sides, right? So let me square that in my calculator, and that's 5.29 equals x. And in this case, it's great that we could solve for x, but make sure to label because it's a word problem. So how many minutes, right? This is how many minutes that it takes for 560 people to get there. Okay? All right, so that's the end of the review.